Alrighty then. Welcome to the Daily Space Weather. I'm your host, Dan, aka Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. The main story of the day today is an uptick in the X-ray flux. And by the way, you might see a little bit of a difference in the format today. It has to do with data showing up at the helioviewer.org site. We've figured out a way to bring you the most comprehensive daily space weather and detailed imagery of the sun you'll find in the known universe. This is 3 different wavelengths from SDO. That's yesterday plus today. That's August 10th through August 11th to date. And again, we've seen a rise in the X-ray flux. And it's kind of odd, really. I suspect what we're going to see is a properly massive sunspot rising up here in the northeast. Because, well, there's not a lot of activity besides that. There is one sunspot that ought to get named. That's this group right here. So that should already be named. It'll probably get a name today. It's very small. It'll be known as it'll be known as Sunspot 3400. And let's briefly talk about the channel. So if you haven't checked out our websites, we built a massive web ring starting back in 2019 in February. In the winter of 2018, we saw the writing on the wall and realized that we needed our own servers because of, well, the state of pathetic censorship on the internet. So we launched Smash-O-Mash.com. And welcome to the Neo Renaissance. Please hit us up over on social media and so on. Press that share button. Press subscribe. Do yourself a favor and get the world's most comprehensive daily space weather video. If you are working for SpaceX or for Blue Horizon or whatever it's called, or for Virgin Galactic, you ought to be watching the channel. And if you'd like to support the channel as a viewer, one of the ways you can do it is through our Hemp Lucid shop, one of our paid affiliate/sponsors. Check out the links below the video to that. You can also find them on the home page, conveniently placed for you right at Smash-O-Mash.com. So lots of different products available there. Some of my favorites are the Mushroom Stress Gummies and the Mushroom Focus Gummies. I highly endorse those, even CBDs for your pets. You can also find an Amazon shop there. We recently added some items to the cycling items. Some interesting suggested reading, including some free ebooks. So head over there also. Maybe get your eclipse glasses through our Amazon shop. Amazon.com/shop/Smash-O-Mash. And last but not least, let's get back. Actually, it's not last or least. Here's yesterday plus today. We will be showing a featured product here momentarily. That is the SDO Continuum. And, oh, there is a new group up here. So there's a new sunspot group. That is a beta gamma class sunspot. And some growth in this group here. This sunspot should be known as 3400. So this will probably be 3401. I think this one's already named. We'll look at that in a moment. Here's the colorized magnetogram also depicting yesterday plus today. So I suspect, again, that there is a large sunspot rising up here. Let me draw an angle. There we go. Oh, there. Oh, look at that. That's pretty. I think that is a sunspot behind that magnetic field organization right there. And let's step away from space for a brief moment to see what's going on Croissant Earth. So first of all, looking at volcanoes, as due to popular demand. We do cover this. And basically what's going on at Fagradalsfjall is while the eruption has ceased, please don't go walking around on hot lava tubes. We don't want viewers like you to become part of the lithosphere by collapsing into a lava tube. So that lava is cooling down, but some of it is still kind of hot at 800 degrees Celsius. So that's basically what's going on. The solidified crust of lava might be very thin, susceptible to break off when walking on its high and sudden. When walking on it is high and a sudden fall through it threatens. Yeah, okay, that's good English. Abiko is erupting, producing an 11,000-foot ash plume over Paramushir Island. Mayan continues to erupt. Collapsing parts of viscous lava flow fronts continue to generate glowing avalanches as they detach from it and roll down to the base of the edifice. at about 4 kilometers distance from the summit. Pyroclastic flows are possible. Please do not get caught in one of those and become part of the lithosphere that way. Also, don't become the bridge between a meteor and a meteorite. That could be unhealthful as well. Ibu is also erupting, producing a 9,000-foot ash plume. It's exploding, in fact. It's a flight level 090, flight level 140 over Semeru, flight level 160 over Fuego, flight level 210 over Sangay. Mild explosive activity over Revenador. Not sure about Sabancaya or Ubinas. Please do not pole vault the caldera. So that's our featured product of the day. Thanks to everybody who's picked up merch. That is actually our best seller on our Redbubble merch shop. You can find links to the Smash-O merch on the homepage at smashomash.com. That one features our URL, our homepage, smashomash.com, smashomash.com. Have you visited it yet? Don't worry, we'll wait. And it also features this public service message at massive personal risk and expense from Smash staff and I. So no matter how bad things seem, don't worry, they can get worse, but they'll get better. Our finest days lie ahead. Please do not pole vault the caldera. Again, don't become part of the lithosphere. You're needed to do important things, or perhaps unimportant things, but go do those things anyway. And let's move on to get back to seismic activity, because we want to know what's been shaken. So there is the past 90 days. A near perfect spacing of 7 magnitude earthquakes there over the past 90 days, which means we're basically due for one. I mean, statistically speaking, we're basically due for a 7 magnitude quake here on planet Earth. And here are the quakes of a 5 and greater magnitude for the past 24 hours, starting with eastern Turkey. That one likely did some damage. It was a 5.3 at 1748 Universal Time yesterday afternoon. Since then, pretty calm until a 5.1 strikes at New Zealand. Looks like it's right on the North Island there. That 5.1 was at depth, nearly 200 kilometers depth, at 183.8 kilometers. Time was 23:53, 7 minutes till midnight. And besides that, it looks like just 2 quakes of a 5 or greater magnitude. There were some quakes here along the Diablo Range in California. That was a 4.3 actually there, near Parkfield in the Cholame Hills. We don't usually report quakes of smaller than a 5 magnitude, but I figured I would cover that one. Next, getting back to space. And yeah, again, we've had an uptick in the X-ray flux here, so I suspect it is from this rising group up here in the northeast. There's not a lot of other explanation for it. Flaring has been, somewhat minimal, only in the C-class range. Flares, the background X-ray flux dropped down to approximately a B-class range there. The upper B-class, very low C-class range. And now it's gone up quite a bit. We'll cover it here in a moment. First, some additional space weather facts. So the 10.7 centimeter radio flux is now at only 156 solar flux units, right around this ongoing support level here. So right here in the mid 150s, you see a lot of peaks and troughs right in there. And that is where it currently is. So am I expecting a double peak solar cycle for cycle 25? Well, not at all. It's still expected to continue ramping up a lot. So don't expect the lull in activity to continue. Now, Dr. Keith Strong will say that he's not expecting any uptick until September or October, but it looks like we've already gotten an uptick in the X-ray flux. So that is one of the many features that we follow when it comes to solar activity. And looking at the Space Weather Enthusiast dashboard, we ain't got no space weather in the forecast. It is geomagnetically calm conditions expected for the next 3 days. Here's Earth's magnetic moment from space for the past 4 hours. We show this daily on the channel because a lot of people are frightened that Earth's poles are going to flip, Well, if that would happen, you'd be seeing all kinds of weird stuff going on in this imagery, but you're not. One of the many reasons why we don't expect Earth's poles to be flipping. We don't see quadrupoles or hexapoles or any indication that the current geomagnetic excursion is a severe geomagnetic excursion, and the geologic record largely agrees. I know people are trying to convince you to buy bunker supplies. I'm less interested in that because of nature and more interested in bunker supplies because of human activity. Here are the past 4 hours of Earth's magnetic moment from the ground. When in doubt, folks, blame humans. I would also note that on this map, you're not seeing any hexapoles, quadrupoles, octopoles, or anything like that. Earth's magnetic moment from the ground is looking pretty unremarkable. Let us know in the comments if you disagree or agree or don't care. Next, the planetary K-index. An average of global geomagnetism is at 1.33. KP 1.33 is the current situation. Again, it is geomagnetically calm. And I don't think we're expecting any impacts here for the coming days. We'll cover coronal mass ejections a little bit later in the video. So the current conditions are extremely diffuse solar wind, showing up here as 1/10 of a proton per cubic centimeter, which is all the way at the bottom of that graph. It's not even like detectable. Largely believed to be an error. And by the way, the instrument recently switched from the Discover to the ACE. So the ACE detecting very diffuse solar wind there, around 1 proton per cubic centimeter on the average for the past couple of hours. Solar wind speed here still over 400 kilometers per second, 439. Besides that very diffuse solar wind there detected by the ACE, that is pretty unremarkable real-time solar wind as well. Moving into the GOES magnetometers here. And those are pretty smooth, as you may have come to expect if you're a regular viewer of the channel. And if you're not a regular viewer of the channel, do yourself a favor and press subscribe. Or, if you don't like my analysis of things, press unsubscribe. Or leave a derogatory comment. We will not be offended by anything that you could possibly say on the internet. I've got what you call a thick skin. So, yeah, subscribe, unsubscribe, whatever. It's all good. That is the GOES 16 and GOES 18's magnetometer for the past 3 days. Moving on to the heliospheric current sheet. Super important, and it gives us mad insight. So I suspect that the reason the South Pole current sheet is hanging out is because, so this is the heliospheric current sheet, right? This is the South Pole oriented current sheet. Here's the North Pole oriented current sheet. And the plasma in the solar heliospheric current sheet, it is oriented to one polar field or another. So at the moment, Earth is kind of right in the middle of this South Pole oriented current sheet. And a good explanation for that is that rising active region in the northeast. So we'll get to that here in a moment. First, our line of sight field plot. So, oh, and by the way, I am expecting Earth to stay in a South Pole current sheet. This is now more consistent with the activity that I see going on at the sun right now. So that brings us to coronal holes. Super important as they show us the solar polar field reversal process, which is what a solar cycle ultimately is. You see sunspots and you see coronal holes showing up at the same time. So equatorial coronal holes are the most geo-effective type, meaning they're the most likely to be associated with incoming high-speed solar wind streams. And frankly, we've been seeing a huge shortage of coronal holes during this solar cycle. We are expecting a huge uptick at any moment, basically. We showed the North Solar Polar Field exiting the North Polar region just a couple of months ago, maybe a month ago, something like that, 6 weeks. And now it's sort of, the floodgates are open for solar maximum. We don't believe us to be there yet. I think there's a long way to go to solar maximum. In fact, I'm expecting solar cycle 25 to slightly exceed solar cycle 23. maybe that's too controversial for you. Before we get to sunspots, let's take a look at coronal holes from SDO. So we're using the Browse Data feature, which does have some advantages to our standard Helio Viewer movies, because, well, the main advantage is that I can rock this back and forth. You see that? I can press pause and I can see when a specific event happened, right? So, I mean, I do use this regularly. We just don't necessarily always show it on the channel because we show custom 24-hour videos. This is a greater than 24-hour video. That's, again, it's yesterday plus today, August 10th and August 11th to date. So we do have a well-defined coronal hole up here. And, yeah, besides that, sunspot activity quite low. So let's move to sunspots next. And again, I suspect this is going to be a sunspot up here. I think there is a sunspot hiding behind that field organization. We should have sunspot 3400, should be named right here. And then, oh, okay, I think right here we'll have another one. No, wait a minute. 3397. Nope, that one's already named. So maybe have one new named sunspot group today, 3400. It is pretty weak solar activity, at least on the Earth side of the solar disk at the moment. Next, we'll move to energetic particles and solar flares. Oh, hey, I'm back. There is the ghost proton flux over the past 3 days and subsiding as forecast yesterday. And here's this X-ray flux I've been talking about. Check it out, the background X-ray output here. Now all the way up to a C2.5 level, at least since this morning, since, let's see, since 1 o'clock this morning, it's gone from a 1.5 to a 2.5 background flux. So that's a big uptick in the X-ray flux there over the past 11.5 hours. And I can't attribute that to anything besides that new active region, because besides that, no major changes in activity. Let's take a look at that from SDO 131 angstroms. So this is one of the best wavelengths to view flares. This is specifically designed to view solar flares. The 131 and 94 angstrom wavelengths, they take more images per minute than the other wavelengths. They are formulated to view solar flare activity. So let's briefly zoom in here, as the most flaring does indeed occur around the equatorial portion. So there's yesterday plus today. There was some activity out of this sunspot group. And again, we're certainly seeing some indications that there is something rising there behind the northeastern limb. So here's 94 angstroms, the other excellent wavelength through which to view flares. Just keep in mind that this is not X-rays. This is extreme ultraviolet light, a lower frequency wavelength of the electromagnetic spectrum. Now, while we do recommend that our viewers have a high school physics level of understanding in order to understand these videos, basically the way it works is, folks, the human eye can only see visible light. These spectra, again part of the extreme ultraviolet spectrum, are not visible from the ground level. These frequencies of light, ultraviolet light, are filtered out by the upper Earth's atmosphere. I think these wavelengths only make it down to the top of the ionosphere level. By the mesosphere, they can't be viewed anymore, so they must be viewed from space. In this case, the SDO, the Solar Dynamics Observatory. So below the frequencies that are below human vision, those are called infrared. Below that, you have things like microwaves and radio waves and so on. Above human vision, you have ultraviolet, X-rays, and gamma rays. That's sort of a breakdown of the electromagnetic spectrum. These are photons. And remember, folks, don't confuse solar flares with coronal mass ejections. They are separate phenomenon. And it looks like part of the uptick in the X-ray flux is also coming from down here. So we do see some flaring down here in the southwestern limb. But the sun has been quite steady here over the past 24 hours. No major changes there in terms of sunspot growth or really even sunspot decay. So let's take a look at what's going on overhead briefly before we talk about coronal mass ejections and filaments. Are you preparing for this weekend? Why? It might be a good weekend to feast your eyes on this area right up here. The area between the border of Perseids and Cassiopeia. That is where you might see Perseids emanating from that point. Somewhere right around here, you might see a bunch of this going on. That is from cometary dust. Swift-Tuttle is the name of the comet. And the Perseids are one of the best meteor showers of the year. If you take some time-lapse photography of that or something, let us know. Hit us up on social media. We might feature it on the channel. So that's what's going on over Lehigh Valley. Jupiter up there high in the sky on the ecliptic. And Venus trailing the sun. If you view that in the evening sky, it'll be quite bright and delightful. Venus, the third brightest object, I'll say my second favorite planet. Here's a solar system forecast to help orient you to where things are located. So this is where things are today. That's where things will be in a week. And if you're frightened that Saturn's going to kill you, just keep in mind that it's really far away. I mean, it's much farther away than Jupiter. This is not to scale. If you're frightened of planets, please press unsubscribe. I'm just kidding, folks. You can be frightened of planets and still watch the videos. And let's move on to CMEs. But before we do that, a brief talk about cosmology. So part of the reason this channel exists is because of cosmology. Hey, that's better. Cosmology. That's part of the reason why I got involved in heliophysics, because I realized in the mid-1990s when I took college astronomy that there's a hole in cosmology, and the hole is heliophysics. I expected a lot of understanding to come out of college astronomy about heliophysics, but it never came. It never came. Now, back then, we used to call black holes massive radio sources, as that is actual science. You can measure the radio emissions from a radio source, even like the supermassive radio source at the core of the Milky Way galaxy, known as Sagittarius A star. Anyway, if you want to learn about the possible future of cosmology, try reading the Robitaille paper. Yeah. 40 lines of evidence condensed matter. 40 lines of evidence for condensed matter, the sun on trial. 40 proofs supporting liquid metallic hydrogen as a solar building block. It's got over 400 science paper publications. It has been peer-reviewed. And did you know it turns 10 years old? Yeah, 10 years old on October 1st. We're going to organize a holiday about it. Hopefully Eugene will co-host our October 1st holiday progress in cosmology party. And by the way, this is one of the most important science papers in hundreds of years. Did you also know that we're in the process of composing a paper that explains the solar sunspot cycles? Yeah, it's pretty serious. And this paper will be cited at least a couple of times. We'll probably have to write multiple papers on it, but in any case, it's pretty crazy. I think I have explained the mechanism that underlies the solar sunspot cycles. We've also got today's astronomy photo of the day. It's totally sweet. It's a galactic merger. So let's scroll down on this high-res image. That pink area that you see there, that is hydrogen gas. So that is likely one or both of the galactic jets' collective outputs. Of course, galactic cores are a known source of cosmic ray flux. There are jets that are blasting out relativistic particles. And no, I don't remember the names of those galaxies. I don't memorize stuff that I can look up. So that's the apod.nasa.gov astronomy picture of the day. A spectacular galactic merger here in progress. It is NGC 5194 and NGC 5195, also known as M51, from the original Messier catalog. Of course, back in the times of Messier, he did not even know about galaxies. They called galaxies blurry nebulae back then. Blurry spiral nebulae. So that galactic merger there, that's perhaps a great desktop for you. And let's move on to coronal mass ejections. So here are yesterday's CMEs. That's 104 frames from George Mason University. And there were indeed some CMEs. And due to HelioViewer being down, it is not helpful to calculate their trajectory. These do not look like Earth-directed CMEs. That's yesterday's images. Today's images might be a little different. So that first one that comes out of the southeastern limb down here, that one, I don't think that has an earthly directed component, folks. The later one, the one that comes from up here, I also don't think that one has an earthly directed component. But let's take a look at some more data, the data we have available. So here's LASCO C2 and C3. And let's bring these both back. So there's the most recent one. That one is coming from the far side, from behind that new active region in the northeast. I don't anticipate that having an earthly directed component. This earlier one, it looks a little more promising, but we'll have to see here. So that started right around midnight. Let's do a further analysis of that. So we're going to look at stereo A briefly here. Feel free to pause the video on this frame. It's showing how close to Earth stereo A is. They're almost perfectly in line with each other at the moment, which is suboptimal for calculating coronal mass ejection trajectories. Stereo B here is now continuing to move off to the east, which means stereo A is going to be behind Earth, seeing older activity. And stereo B will be ahead. They're switching positions. And at the same time, stereo A showing a bunch of erroneous looking data there. So not sure what's going on with stereo A, but I am disliking that. Let us know in the comments what you think. Let us know in the comments what you think is going on with stereo A. It looks like maybe damage on the aperture. I don't know. It's clearly something is clearly wrong there, as that is not what the space around the sun looks like. No other instruments showing that, so it's pretty weird. I don't really have any clue what that might be. And so let's get rid of it. Bye. So here's LASCO C2 again. We've got some more frames here in a little larger size. So I suspect there are events happening at the same time here. Again, that's right around midnight, so it should be pretty easy to figure out if there is an earthly directed component here. And let's show you how, as we want you to be able to forecast your space weather. So what we'll do here is demonstrate how to do this. We're going to bring up the SDO browse data once again. I'm going to press pause, and I'm going to advance this to just around midnight. So we should see a CME right around midnight here. All right, and it came from right in here. So again, this looks like it is behind the solar limb. I do not anticipate it to be earthly directed. And that is my analysis. So the 304 angstroms wavelength is great at showing filaments, which transitions us perfectly into the next section of the video, which is solar filaments. We've been naming them after living people. Go join us over on X, the platform formerly branded as Twitter, now rebranded to a letter, which, by the way, is not a brand. And here is the hydrogen alpha imagery from El Teide, Spain, in full color glory. That is just splentacular. And we still have most of the Donna Marie filament is here in place. Here's the Kate Bush filament. The Mike Smith filament still intact. And the Meghan Markle filament, well, it's actually relocated itself. In fact, that CME from around midnight may have been the Meghan Markle filament. So huge filaments down here as well. So it is definitely 100% likely to see additional plasma filaments ejecting, a feature known as coronal mass ejections. Again, not to be confused with a solar flare. Folks, I can't stress it enough. A solar flare is photons. Those are X-rays, as I discussed earlier. A coronal mass ejection is gas, diffuse protons, mainly hydrogen nuclei, but also some helium, and then some other heavier elements known as metals in the realm of cosmology. Photons and protons. Don't confuse them. A flare is not a coronal mass ejection, and a coronal mass ejection is not a flare. They are separate features. We see flares regularly with no coronal mass ejection, and we see coronal mass ejections regularly with no flare. By the way, if you want to name filaments after living people, again, join us over on X. You'll see some content you won't see elsewhere. And what the heck? I missed something here. Let me go back. All right, and there's the El Teide Ground-Based Solar Observatory Hydrogen Alpha imagery, which is just zoomed out a little bit. It is the same wavelength. It doesn't look as cool as the in-color one, but it does show prominences. So this is what we used to show, and now we also show the in-color image because it does show a little bit greater contrast. Yeah, there are some filaments that could get named here, namely these down here. So if you want to name filaments after living people, again, join us over on X, the, quote, social media, end quote, platform formerly known as Twitter. Here are the past couple of hours. Again, we'll be streaming and keeping an eye on this area up here in the northeast. And when I say eye on, pardon the pun. By the way, the GO 16 shows the last approximately 2.5 hours of solar activity. And you can find our Twitch channel streaming most of the time at smashomash.com/smashteam. Did you know NASA pays people to sit there and stare at this all day long? Yeah, because they have astronauts in space. They want to know right away when a flare happens. Because the light shows up faster than even relativistic solar protons. So let's move into our bonus features segment. Don't be a boner. Stay tuned for our bonus features segment where we talk about things like the electron flux, the ionosphere, and satellite charging hazards, which is our first order of business. Satellite charging hazards are currently non-existent. It is smooth sailing. No surface or internal charging hazards. No electrons on the outside or inside of spacecraft building up, causing communications breakdowns. The GOES electron flux here looks like it's just about to reach into minor warning levels there for the GOES 16. Once again, it looks like the GOES 18 is leveling off. And if you're wondering what those N's and M's stand for, those are midnight and noon local time for the satellites, giving you an idea of their geosynchronous orbital locations. Noon and midnight local time for the satellites. There is the 1-year graph to contextualize the relativistic electron flux measured at the F layer of the ionosphere, which is what we'll show next after the NOAA forecast. So there's the forecast, expecting relatively flat levels here in the coming days. No arguments from me there. Next, we'll show the vibrational frequency of the layer where it's actually measured using radiography from those geosynchronous satellites, the F layer. And here's the vibrational frequency of the bridge between Earth and space. The upper ionosphere, a slice of the atmosphere located at about 300 kilometers of altitude, is what you're seeing here in vibrational frequency. Megahertz, which is millions of vibrations per second. You may notice that the highest frequency portion is around the equator at noontime, which is what you'd probably come to expect, as that solar radiation is causing the ionosphere to heat up in that area. And we'll also show the anomalygram, because frankly, it's hard to understand the ionogram. So we show the anomalygram depicting anomaly in megahertz from a 30-day median daily on the daily space weather show in order to get an idea if anything weird's going on. And nothing weird's going on. The ionosphere looks quite normally, which, by the way, it would not look quite normally if there was a major polar excursion going on. If there was something to be spooked of, you'd see constant anomalies in the ionosphere and the total electron content and so forth. But we don't. I'm not frightened in the slightest of space. Space, a frontier. It's not going to kill you. Here's the latest image. That's 11:45 Universal Time ionogram. And here is 11:45 Universal Time anomalygram. Total electron content depicts free electrons to about 12,500 miles of altitude. And if your satellite has to communicate through a lot of free electrons, you get signal refraction. So for GPS, that's an issue. It causes GPS errors. So let's take a look at the total electron content forecast to show where those errors are most likely. All things equal, the most likely place to see GPS errors is around the equator at noontime. However, sometimes we see that get a lot less organized. Another thing that you would expect to see all the time during a major polar excursion, but not. Fairly organized. As we show regularly on the channel, the GPS errors on planet Earth are pretty much where you'd expect them to be, centered around the equator at noontime. Now, of course, there is the South Atlantic anomaly. That is the weakest spot in the magnetosphere, but it's been quite stable and quite consistent for years and years. Last but not least is the total electron content anomaly from the 10-day average over North America, and it looks like limited data there. I don't know what's up with that. It looks a little funky. I wouldn't spend too much time worrying about that either, because you probably have important stuff to do. So let's take a look at the latest intensity gram. Here's the latest colorized magnetogram. New sunspot up here. New sunspot right here. Those should both get names today. And do we see one rising yet? Nope. Well, there might be. I think it is. I think there is a sunspot there. I'm starting to see a dark umbra there. Did you know that some of us believe that sunspots are dark because they're flat? Yeah. It's not an illusion. They're dark because they're flat. And it's... Read the Robitaille paper, The Sun on Trial, 40 Proofs Supporting Liquid Metallic Hydrogen as a Solar Building Block. It provides valid physics explanations for most of what we see happening on the closest star. Anyway, here's your full disk rockback. The most likely place to see a major flare is probably up here, but also here. This sunspot shows some signs of activity, and also this group is beta gamma class. Let's actually check the classes of those briefly. That is beta gamma delta class. That is That's beta gamma class. This one down here, that one is beta gamma class. Oh, some minor deltas in there. Anyway, did you know that solar flares can be forecasted? Yeah, it's all about the magnetic shear. When you have two umbrae that are of opposite polarities and are close to each other, that kind of sunspot is much more likely to produce especially a large solar flare than a sunspot without those close together opposite magnetic fields. We call that magnetic shear, and that magnetic shear is how solar flares are forecasted. It's just a fact. It's not a mystery. Solar flares can be forecasted. It's just really not that big of a deal. The sun's not going to kill you. So let's move into our meteorology segment here. And we're going to start out by looking at Saharan dust. So we talked about this a little bit yesterday on our live stream. Saharan dust. Here is the central Atlantic Ocean, and it looks like there's another significant dust storm here coming out of the Sahara. And all of that dust does not encourage tropical storms to form. So, just so you are aware of that, that dust does not aid in convection. It tends to tamp down systems. And also there's a mild anticyclone right over here in the subtropical Atlantic. That doesn't help things either, as that creates wind shear, which also breaks apart tropical systems. Anyway, let's take a look at the winds from around planet Earth. We'll show you three views. Looks like this system has intensified a little bit southeast of Japan. So that's the surface wind scenario for the eastern world. Here's the jet stream scenario for the east. Powerful anticyclone here north of India. Check that out. That is a powerful anticyclone. It is a clockwise rotating high pressure zone in the upper level. Perhaps similar to Jupiter's Great Red Spot. Did you know Jupiter's Great Red Spot is nothing like a hurricane, just like a sunspot is nothing like a hurricane? An anticyclone is a high pressure zone. In other words, there are likely clear skies over this area. Keep in mind, Earth is not a gas giant. So an anticyclone behaves a lot differently on planet Earth than it does on Jupiter, which is a gas giant. Here are the jet streams of the central world. And they are blowing backwards over northern Africa and the northern Indian Ocean. Here are the surface winds of Europe, Africa, and the Middle East. Here are the surface winds of the West, the Americas. Looks like a significant low here right off the coast of New England. And here are the jets. That's the 250 hectopascal winds of this side of the planet. And let's take a look at snow. So of course this is going to be controversial, but guess what? A foot of snow, over nearly 13 inches of snow, just recently fell on Greenland. So there's new snow. Is that the forecast? Oh, that's the forecast. So a foot of new snow expected on Greenland. All right. And let's just take a look at snow depth while we're here. As Greenland is running out of time to melt and frighten people and cause people to be very spooked that the Atlantic meridional overturning circulation is going to shut down, creating a year without a summer. Well, guess what? We're approaching autumn, after which is winter. And if you're wondering if I'm forecasting a year without a summer next year for Europe, the answer is nope. Nope. Anyway, that's snow depth from around the world. And let's take a look at some analysis of snow and ice. Yeah, snow and ice. People are very concerned about it, so let's take a look. So here's permafrost. Here's the Alaska permafrost thaw depth. You can see the thaw depth has been rising there since at least 1990. So that's a thing. I mean, that's an indication of what? Warming? Yeah, warming. How about active layer thickness trends of permafrost? And it looks like we've got some interesting higher thickness with the active layer there, especially at Alaska. As far as Antarctica goes, all right, I'm not too familiar with permafrost. Let's take a look at sea and freshwater ice while we're on globalcryospherewatch.com. So here is the sea ice extent. You can see it's kind of low here. It's around the, which one is that? That is the, around the 2010s, just a little higher than the 2010s average there. Not nearly as low as 2012, and not nearly as high as the 1980s. There is Arctic sea ice intent since around 1979 when it was at a measured high of all time. And what else do we have here? Oh, here's cryosat ice thickness. Oops. Not available in midsummer, folks. So let's move on to snow. So here's the multi-sensor snow. And it's fairly snowy around the North Pole, wouldn't you agree? Let's also look at South America and Australia and New Zealand. There you go. Kind of in the middle of the range there. It never got very high this year, so a lot of global coolists will ignore this graph and not show it to you. We show you all the data, all the facts, because I'm fans of nothing but the truth. Here is Australia and New Zealand, having recently had a big uptick in their snow extent. Looks like New Zealand was the source of that. And let's move on to regular old everyday meteorology stuff. So here is shortwave radiation depicting clouds and fog over the Americas. We're zooming in from space all the way to the lower 48. Clouds and fog depicted by the NASA GOES Interactive Weather Satellite Suite shortwave radiation map. Here is firesmoke.ca's smoke forecast. Some thick smoke coming to Maine especially. And it looks like they don't cover Hawaii. So that's your Canadian smoke forecast. Compliments again of firesmoke.ca. Next, our US weather.gov map. Weather.gov, if your location is highlighted on the map, feel free to visit it. We've scrolled down to show you the color key. It looks like at least the winds have calmed down at Hawaii now that the damage has been done at Lahaina. Anyway, weather.gov if you want to get that. And next, some forecasts. So we've put together 3 GFS 72-hour forecasts for you today. First, the GFS 72-hour temperature anomaly forecast in degrees Celsius. Some very, very hot temperatures, especially coming to East Texas and Louisiana and southern Alabama. I'm sorry, southern Mississippi and Alabama, and the Florida Panhandle. Something like 16 plus degrees Celsius above normal there. And some wild temperature variations in Colorado, perhaps produced by all the hot air coming out of that state. Next, pressure and precipitation based on the same model, the GFS 72 hour. Heaviest weather here in the coming 3 days, likely to strike Iowa, especially the western part of the state. And here's your 72-hour GFS, a jet stream forecast, the 250 millibar winds. And it looks like a bit of an anticyclone here hanging out over the Gulf states. So it looks like clear skies coming to the Gulf states. Next, your lightning mapper. That's the past about 10 hours. Strongest lightning on this map off the Atlantic coast, off of places like Virginia. And let's look at real-time lightning from lightningmaps.org. What do you got? Here we go. There are some active cells west of Peoria. There is thunder rolling in. In some places. Those are the places. By the way, if you enjoy the content, make sure you unsubscribe from the channel. It's all about views, folks. We don't care about subscriptions. It's all about views. If you want to support the channel, seriously, become a member of the Smash Team, smashomash.com/Smash Team. Did you know we send out email alerts? Even to unpaying Smash Team members. The bronze level will cost you $0 per month. Silver level, to get additional content, is $2.99 a month. And gold level, which is additional content and all kinds of other features, is $9.99 a month. Save some cash on that effectively by becoming a gold annual paid-up subscriber. That's the best value. It's almost like getting 4 months of a gold membership for free, as it includes complimentary merch. We don't say free merch, we say complimentary merch, because nothing is free, folks. Nothing is free. So hit up the Smash Team site, sign up for email alerts. You'll get alerts about videos just like this one, as we've had a number of complaints that people are unable to see the notifications on certain video hosting platforms. Speaking of which, did you know that we've recently moved up to like 3,000 views a day? Thanks to our new YouTube viewers, our loyal, long-time YouTube viewers. And if you want to press the share button, especially with low attention span people, hit up our shorts. We put out shorts every day that are largely excerpts from these videos, but also some other content there. Shorts are videos that are less than 1 minute in length. And of course, many, many highlights there showing up in the shorts. Again, thanks to our new subscribers, our longtime subscribers, but especially thanks to the Smash Team. Because these videos are brought to you at massive personal risk and expense by Smash staff and I, and some of that is offset by our gold and silver Smash Team members. So if you'd like to see the content remain visible, publicly visible that is, free for all to view, and existent, help support the channel via our links below this video as well as on the homepage at smashomash.com. We're going to close this mother out. And let's pause for station identification. This is the Smash News Network, least busted name in news. And this is radar.weather.gov. We'll briefly show you the full 50-state view. There is the full 50-state view as we zoom in to the lower 48 view. Strong storms here about to strike Chicago. We better hurry up and get this video onto your screen, as the premiere will be happening just as that rain arrives in the Windy City. Here's clouds and fog, once again shortwave radiation on the NASA GOES interactive weather satellite suite, a space-based system that shows clouds and fog at night, and here is water vapor. Check out the constrainment. This is a great example of constrainment. You've got this low, which is moist air, running into a high, which is dry, more massive air. And behind it, it's being pushed by another high as more moist air collides with that, creating pressure gradients and so forth. You've got an impulse up here as well, pushing this forward. That will not help to intensify this relative low. But that's a little bit of atmospheric physics for you there. Remember, folks, dry air is more massive than moist air. That is why an anticyclone has to do with clear skies, because nitrogen is more massive than oxygen. I mean, more massive. Nitrogen is more massive than water vapor in the atmosphere. So N2 is heavier than water vapor. That is why you have low pressure on a rainy day and high pressure on a clear day. Here's the recap. U.S. Doppler radar, clouds and fog, and water vapor. And thanks for tuning in. And congratulations on realizing the channel exists. We remain frankly surprised that you've found the channel with the pathetic, putrid, disgusting, ridiculous, and evil state of censorship on the internet. We'll see you soon. We'll come back to space tomorrow and tell you all about the weather, all the way from the lower 48 to the closest star. Anyway, see you soon. I'm going to head back to the bunker and make sure that it's stocked, because I'm very spooked of space because I've been listening to too much nonsense on the internet about it. Bye! I'm going back to the bunker again. Whoa!